How Ethereum and Metachain work. Stay tuned and you will get the answer by the end of this explanatory video of how each the Ethereum network and the Metachain work. First, let's dive into the Ethereum network, then we'll move on to Metachain's mining techniques, and we'll elaborate how each is different from the other. Imagine Ethereum as a single decentralized system, existing on thousands of computers worldwide, thanks to users participating as nodes. This isn't your typical network, though. It's decentralized and resilient, practically immune to attacks and outages. If one computer goes down, it's not the end of the world. Thousands of others are holding the network up. At the heart of Ethereum is the EVM, a sort of supercomputer held by each node. Every interaction on the network must be verified so everyone can update their copy of the EVM. These interactions, or transactions as they're known, are stored within blocks on the Ethereum blockchain. Now, these blocks don't just appear out of thin air. They're validated by miners before being committed to the network, effectively acting as a digital ledger or transaction history. This process of mining to verify transactions is known as a proof-of-work consensus method. Each block has a unique 64-digit code identifying it. Miners commit their computer power to find that code, effectively proving their work. They're rewarded in ETH, Ethereum's native cryptocurrency, for their efforts. All Ethereum transactions are entirely public. Miners broadcast completed blocks to the rest of the network, confirming the change and adding the blocks to everyone's copy of the ledger. These confirmed blocks are tamper-proof, serving as a perfect history of all network transactions. But here's the kicker. If miners are paid for their work, where does that ETH come from? Each transaction comes with a fee, called gas, paid by the user initiating the transaction. This fee is then paid to the miner who validates the transaction, incentivizing future mining and ensuring network security. Gas essentially serves as a limit, restricting the number of actions a user can make per transaction. So, Ethereum is a decentralized network where transactions are validated by miners and recorded in a secure, transparent, and tamper-proof digital ledger. It's a remarkable system, shaping the future of the digital world as we know it. But Ethereum isn't without its challenges. As we dive into the dynamics of gas fees and network congestion, it's crucial to understand how these elements work. Gas fees are essentially transaction costs that users pay to miners who validate their transactions. These fees serve two main purposes: incentivizing miners to keep the network secure and limiting network spam by restricting the number of actions a user can make per transaction. However, when Ethereum's network becomes busy, a significant issue arises. Each block on the Ethereum blockchain can only hold a certain amount of gas, which varies based on transaction types and amounts. Users end up competing to get their transactions validated first by offering higher gas fees. This competition escalates the fees and congests the network, making transactions slower and more expensive during peak times. So while Ethereum offers a lot of benefits, it can also suffer from high transaction fees and network congestion during busy times. Now, let's shift gears and talk about Metachain, another interesting blockchain platform. Metachain, like Ethereum, operates on a decentralized system but aims to address some of the issues faced by Ethereum users. Its purpose? To provide a seamless and cost-effective platform for executing smart contracts and decentralized applications. Unlike Ethereum, which employs a proof-of-work consensus mechanism, Metachain uses a proof-of-stake model. This means that validators are chosen to create new blocks based on their stake, or the amount of tokens they hold and are willing to bet on the network. This reduces the energy consumption significantly and allows for quicker transaction processing. One of the exciting features of Metachain is its scalability. It's built to handle a large number of transactions per second, which can help reduce network congestion. Plus, it has a unique solution for gas fees, ensuring they remain stable and predictable, regardless of network activity. Metachain, while not as widely known as Ethereum, offers its own set of benefits and features that make it an interesting player in the blockchain space. It's time to put Ethereum and Metachain head-to-head. How do they stack up? Ethereum, with its decentralized system and infinite supply of Ether, is a robust platform that's immune to attacks, highly reliable, and offers transparency with its public transactions. But Ethereum does have its drawbacks. High gas fees and network congestion can be a hurdle, especially during peak periods. Metachain, on the other hand, offers a unique approach. While it maintains the spirit of decentralization, it aims to tackle Ethereum's problems. Metachain's architecture is designed to handle large volumes of transactions, promising lower fees and less congestion. However, the use cases for both can vary. Ethereum, due to its mature ecosystem, is ideal for developers and users seeking a proven platform for decentralized applications. Metachain, still in its nascent stage, might appeal to those who are looking for a cost-effective alternative with potential for growth. Whether Ethereum or Metachain is better for you depends on your specific needs and circumstances. Both have their strengths and weaknesses.